Okay, so we have seen what is conservation of mass equation. Consists of what happened in a control volume and what happened in a control surface. And then we consider two scenarios. One is incompressible, we get this equation. And then when we have a steady compressible, then we get this equation. Look at one tutorial question. So if you go to Moodle and download chapter 3 tutorial, this is fall under question number 8. So you have a diagram like what you see on the screen here, right? So we have a pipe with 3 inlet or outlet. So in this case, we have 3 points that we need to consider. So we have point 1, point 2, point 3, and point 4. So what information is given? So in this case, consider a steady flow. So the word steady come out already. So you can write the equation and then do the necessary arrow cancel, and then you get the 2 marks just for the proof that you understand what mean by steady flow in the continuity equation. So the area 1 is given, 2 is given, 3 is given, and somehow there's a area that is opening at point number 4. The float is lost at hole number 4. There's a hole number 4 here. Estimated at the rate of 0.1 meter cube per second. So this is a Q, meter cube per second is your Q at number 4. The average speed at section 1, 3 is given 5 meter per second and 12 meters per second. Find the velocity at section number 2. Okay, so all the parameter is given. You are given velocity at 1, velocity at 2, velocity at 3, and then Q at number 4. So again, to solve this kind of question, to solve the velocity at number 2, in our idea, we call out the conservation of mass. Means what go in will equal to what go out. So then we balance the whole system. Okay, so we have a steady flow. Flow rates all is given, and the density of the water is 999 kilogram over meter cube. So in exam, the temperature will be specific mentioned. So you need to refer to Appendix A according to a certain temperature. Okay, so at the standard case is 999 kilogram over meter cube at 15 degrees C. Yeah, standard case is 15 degrees C. Okay. So we need to find number 2, velocity. Solution, we have a control, because in the continuity equation, we have 2 components. One is control volume, one is control surface. So we need to draw a control volume from the diagram. So first step is to draw the control volume. Then we make assumption that the flow in I think something missing here. Flow in section section 3 is going outward. Section 2, I think this one. We assume flow at section 2 is going outward. Yeah. So at section 2, we assume that the flow is flowing out like that. Although there's no direction given here, but we assume first. So when you assume it's going this way, but when you get negative value, means what you assume is wrong. You just explain about the negative sign. Yeah. So we assume that steady flow, this is what given in the statement. We have incompressible flow, and we have a uniform properties inside there. So you look at the statement here, there's no incompressible mentioned, but however, when you come to a test or exam, section 1 or section 2 or section 3, one of section will mention, assume the flow is incompressible, calculate what. Assume what, then calculate what. So you get this kind of statement. So governing equation, call out the continuity equation. Again, continuity equation is come from conservation of mass. We talk about mass. And then you, in the continuity equation, actually is a Q. is your it's not Q, it's your m dot, right? It's a mass flow mass flow rate. How you know mass? Again, you take rho times the volume, you get mass. Divided by T, you get m dot. Yeah. So same with the second one. Again, be careful on the second term. Don't write the del over del T here. You don't need this one because the second term is deal with the velocity and area. Yeah. So again, because of steady flow and incompressible float, so in exam, you write this one, you get 1 mark. Then you factor out the rho. This one, you take out, you write incompressible. You get 1 mark. And then steady flow, you cancel the whole thing. You write steady flow. 0 equals 0. You get another mark. So by having these three assumption, you write this equation, get 1 mark. You do some marking on the equation. For example, this case, incompressible, cancel the, or you write rho equal to constant also can. So you'll get 1 mark for this statement. Yeah. And you draw an arrow to cancel the first term. You write steady below the arrow, you get 1 mark. So by this notation, you get 3 marks already, 3 marks in a row. Then you summarize until the final answer. Integration of v dot dA equals 0. Okay, sometimes this equation also give you 1 mark. So it depends on the complexity of the question. So at this stage, you can see that when you write the equation and then you know how to simplify equation, it will give you some marks already. So normal one question will be 25 marks. So up to this stage, you score nearly 5 marks already out of 25. Okay. So because we have three area or 3 surfaces here, we need to consider. So we will add up all the surfaces, or what happened to the surfaces here. That's why we write a notation of summation of what happened to the surface equals 0. Okay, we have this equation on the screen here. Summation of velocity times area to all the control surface. So in your answer, you copy the shape of the object given, then you draw this control, you can say control volume or control surface also can. But normally we'll treat this as control volume because when you have a volume, it was same as your control surface. Okay, you draw the dot line on your answer. You copy out the shape of the object and then you draw the control volume, CV, you label as CV. You will get marks for this dash line. Yeah. So just now you score like 4 marks for equation. You get 1 more mark or 1 more point for drawing out the diagram with the control volume. You get 1 mark. So up to this stage, you get 5 marks already. 5 out of 25. Right? Quite easy to score before you solve the question. All right. Now I'm going to explain a little bit. I'll go slow a little bit. Yeah. So we have how many surfaces here? We have 1 surface, 2 surface, 3 surface. Here, 3 surface, 4 surface. Yeah. So by drawing the control volume, you know that you can focus on the faces of the system. So the first one is at point 1. Second one is point number 4. Third one is point number 3. The fourth point interest is point number 2. Yeah, clear? Everyone, clear of the area that we're focusing on?
Yes.
Okay. Now then, you look at the governing equation is the dot products and it's a vector dot product. Yeah. vector dot product, so you write according to the surface. So the first one is the first control surface. So you write v1 dot a1 plus the second surface v2 dot a2 with the vector sign above here. So then the third surface and the fourth surface. So we have 1, 2, 3, 4. Now the next step, I'm going to slow down a little bit further because I need to explain it in detail. Yeah. So pay a little bit more attention to the following slides. Okay, we focus on point number 1. Point number 1, which is here. So if you look at the first term here, first term consists of two vectors. One is the velocity vector. One is the area vector. So how you determine the direction? Velocity vector is given in the answer in the question. So for example, the velocity is going in this way. So you draw your velocity vector going into the area number 1. This is the first step. Then you clear with the velocity already. Second step, you look at the area. How you draw the vector for area? You look at the opening. Opening will point to somewhere. The opening will point to somewhere. Then you draw the arrow of the opening of the surface. Understand, yeah?
Yes, sir.
Okay. Now, then the next steps will be the products of these two arrow doesn't same direction. You will get a negative sign when you transfer vector form into scalar form. This is vector dimension. Later you will see scalar. This is vector dimension. You convert into scalar dimension, means without the arrow above. Which is you only consider the magnitude of that particular with a negative. So v vector 1 dot a vector 1, you draw the free body diagram, you look at the velocity direction given, and you draw the pointing of the area. In this case, the area is pointing upward. So if you see, look at the arrow. If the arrow is opposite direction, you will get negative sign in the answer. Negative sign, and then you take the magnitude of the velocity times the area magnitude. Clear, yeah? So make sure you understand the signage of the vector. All right, I'll move on. If you look at point number 2, point number 2 is here. Again, you are taking vector 2 dot vector A2. This is point surface number 2, which is here. So again, in your free body diagram, you draw the opening and then you label number 2. So you always start with the direction of the velocity or area. I will prefer to draw area first because area is quite direct. So I will draw the area and then you look at the area, you look at the opening, where does it point to? So in this one, it point outside. So it point outside, then you draw going down, then you label A2 vector. Velocity, in this case, we assume, yeah, this direction we assume. We assume it's going down. Why? Because in the question is empty there. In the question, there's no arrow here. So you need to do your own assumption. In the test also, it will be the same scenario. You need to assume a certain direction of the flow. Okay, so we go back to this example. So point number 2, we assume it's going down. So this question I'll go to Amir. So when you write the second one, vector 2 dot A2, it is positive or negative?
Positive.
Positive, because it's the same direction,
Yeah,
you
same
use
direction.
positive. Then you write the magnitude of the velocity and magnitude of the area. Okay, good, Amir. All right. So anyone want to ask me question? Why certainly we use positive? And then why we use negative for the first one? Anyone have a question? Need me to repeat?
No, that's clear.
Clear?
Yeah.
Okay. So because this area is one of the major area that student will make mistake during exam. They'll forget to put in the notation positive or negative in the exam. So this is also be careful. So I just want to remind all of you not to okay, about this one. So remember to draw the free body diagram about the flow and about the velocity and area. So number 2 we already explained. What about number 3? Yeah. What about number 3? V3 dot A3. Are you able to write the answer? Is it positive or negative if you look at point number 3? What do you think?
Positive.
Constant.
Constant? Positive, yeah?
Yeah.
Yes, positive.
So you know, so when you draw point 3, first I would like to draw the arrow, the area first lah. So it's pointing outside, so always pointing outside. So this is your A3. Then you look at the diagram. What is the direction of flow? The flow is flowing out, V3. So you look at these two arrows, same direction, so it's positive. Then you write the magnitude, V3, A3. So this is how you convert from vector form into scalar form. So this is the important concept when you deal with momentum equation or continuity equation. Yeah. So it will be the same when you deal with momentum later on. Okay. We have clear for the third one. Then you combine everything into the equation. You put everything into the governing equation on the top of the screen here. The rest is substitution. Right? So the question asks us to find V2. You rewrite the equation according to what question 1. So V2 as your term equal to V1 A1 minus A3 V3 minus Q4 divided by A2. Then you substitute the answer. The substitute all the parameter given. V1 given, A1 given, Q4 given, V3 given, A3 given, A2 also given. Only I need to remind is that be careful on the unit given. Sometimes in the exam, we like to give you area in mm square, millimeter square. So you need to change it to the meter square. So remember, you need to change to unit SI. So just as a checkpoint, I do not show the detail of the calculation. Just a checkpoint, you will get V2 equal to negative 4.5 meter per second. So this is the application of a continuity equation for this one. Yeah. So again, you get a negative sign here. It means that what you assume just now for point 2 is wrong. So it means that you have a backflow or you have an inflow at number 2, at point number 2. The flow is going inside rather than going outside. Yeah. So there will be a section of question, maybe section C or D. Try to explain the direction of the output or input. So whether it's going in or going out from that particular surface. So you need to explain by using your answer. Can, all right. So we'll go through another example in our next class. We stop here. Let me stop the recording.